Welcome back, guys. This is lesson 2, session 2. And we are on the apply it problems. So for the apply it problems, you should have them all complete before watching these videos. I'm not going to give time to pause in these videos as many times as I would have in the previous ones. So make sure you have these complete, or at least you've tried them first before watching this. So if you've just turned this video on and 6, 7, and 8 on page 28 are not done yet, please make sure to go try them first and then come back to this video. For people who have already completed these problems, you're going to stay on the video. I'm going to show you how to do each one within this video, starting with number 6. So number 6 says, forest managers plant trees in a triangular section of the state park. The managers model the area on grid paper. Each grid square represents 1 kilometer squared. What is the area of the section that the forest managers plant with trees, and show your work? So in the last lesson, and if you forgot, you can head back to my YouTube channel and find lesson 2, session 2, model it, part 1 and 2, if you need a refresher on this work. In this last lesson, in the model it section on YouTube, on the YouTube video, on page, and it also is page 26 in your book, we found finally the formula, not how you spell formula. We found the formula for the area of a triangle, which we found to be area equals 1/2 base times height. So what we need to do here is, first of all, we need to follow our PEMDAS, right? With PEMDAS, we're going to do parentheses first. So the first thing we need to do is find the base and the height of this triangle. For this problem, I'm going to have my base be green, and I'm going to have my height be orange. So the first thing I'm going to do, step 1, is to find base and height. All right, so let's look at our triangle. Take a couple seconds here to pause the video and find the base and height on your paper on page 28 of your book. After you've paused the video and found it for yourself, I will now show you where the base and the height are. So remember, the base can be any side. A base can be any side of a shape. Any side. It could be this one, or this one. I like to pick the base that is perfectly lined up on the grid paper. So you can see that this line here is perfectly aligned with the grid paper. That's going to make it easier to count how long my base is. After I find my base, I'm going to look for my height. And remember, your height is the perpendicular intersection from the base to the opposite side. So there's a couple things here that we need to take into account, because the height is a little bit hard to find. And remember that the height of a triangle is the perpendicular line from the base to the opposite vertex. Remember, we talked about those corners. A vertex is any corner of a shape. So we're going from the base, which is our green line in this problem, to the opposite vertex. So looking at my triangle here, and I'm going to zoom in just a little bit, we found our base up top, and now we need to draw a perpendicular line from the base to the opposite vertex, which is this guy all the way over here. Remember, it has to be perpendicular. It has to have that perfect L shape, that right angle. So right away I notice, well, there is a line going from my base to my opposite vertex. But is this a right angle right here? No, right? That's not a right angle. That's not a perfect L shape. So that can't be the line that I use. And anyway, that's the base, right? Because the base can be any side. So what do I have to do? If I do draw a perpendicular line from the base and go straight down, I don't hit that opposite vertex. I stop in the middle, and my triangle is taller than that, right? It goes all the way down to here. So there's two ways, actually several ways you can draw this. I'm going to show you two of them. So we can start from our base and we can draw straight down past the outer end of the triangle until we're aligned, matched up with that opposite vertex. And we could take this as our height. Your other option is to start at the vertex and draw straight up until you hit the line that the base is on and use this as our height. Either way, you have a perpendicular line that starts at the base and stretches to the opposite vertex. Here's our height. Take a minute to check your work and pause the video. After we found our base and height, we need to find the lengths of each. So I need to know, so I can start filling in my area equation here, which I'm going to take 1/2 times the base times the height. So how long is the base? What is the length? Take a couple seconds to pause the video and count for yourself. The base is 6, right? So I have 1/2 equals, in parentheses, b times h. I know that this one is 6. My base is 6. And then I'm going to do the same thing, and I'm going to find the height of my triangle, which is right here's my height. I'm going to count 1, 2, 3. And I'm going to add my 3 in right here. I'm going to move my work over to my whiteboard just because my paper is getting a little crowded. I want to make sure everyone can see exactly what's going on here. So I have found in our last lesson that to find the area of a triangle, we can do 1/2 times the base times the height. I need to move this over. Actually, I just need to zoom out here. Still learning how to use this, of course, as we are with everything this year. So A equals 1/2 base times height. I just found my base, which is 6. And I found my height, which was 3. So remember, thinking back to our last video, we saw that when I take a triangle, like this one here, this is actually the one we're using today. When I take this triangle and I make a perfect copy of it, so I'm going to do that just by tracing it. When I take a perfect copy of this shape and I flip it and put the copy along the other edge, we see that perfect parallelogram. This parallelogram has a base of 6 and a height of 3. But remember, this gives me the area that includes all of this. And we only want to know the area for the pink triangle. So what do we have to do? We have to take our 6 times 3, and we need to divide it in half because I'm only looking for this half. One way to do that is to multiply by a half. 6 times 3 is 18. 18 times 1/2 is the same as 18 divided by 2, which in this case is 9. So to come back to our sheet here, the area of this triangle is 9 kilometers squared. Take a quick break. Pause the video, take a quick break. We're going to move on to question number 7. All right, everyone, we're back. We are going to move on to number 7. Number 7 says, and actually, this is a quick tip. If you're ever doing a problem and you just want to look at one problem at a time, just go ahead and cover up the other one. This one is pretty straightforward. It just says, what is the area of the triangle, and show your work. So the first thing I always need to do is write down the formula that I'm going to be using. In this case, I'm talking about the area of a triangle. So I know that I need the area of a triangle formula, which equals 1/2 times the base times the height. And I need to find the base and the height first. So looking at this triangle, how am I going to find the base and the height? Pause this video now to take a couple of seconds to see if you can highlight on this shape the base and the height. So just like my last problem, I'm going to use green for my base and orange for my height. And the first thing we need to do is find base and height. So let's see. I know that my base can be any side of a parallelogram or a triangle or any shape. The base can be any side of any shape. I have 3 sides to choose from. This bottom one, that says 10. This one, that says 10. And this one, that says 7. So how do I choose? I'm not really sure. I'm not sure which one to pick right now. So I'm going to move to my height. Because what do I know about my height? It makes a perpendicular line with my base. The only perpendicular lines I see on this triangle are this dotted one that go down the middle. That matches up with this line right here. And I can see that because it makes this right angle that it's showing us. So if that's my height, then my base that I want to use is going to be this line right here. Right? I always want to choose the perpendicular lines when I'm looking for my base and height. That's either going to be that T shape or that L shape. Now that I found my base and height, I just need to take out the measurements. How long is the base? Well, we said the base was this green line because it's perpendicular to the height. And my base here is 7. I'm going to write a 7 right here, and I'm going to put the rest of my equation in. I'm not using it yet, but I don't want to forget about it. We all know I'm a little forgetful, so I always want to write that stuff down. Then I need to multiply by my height. We found our height was this line going through the center because it's showing me how tall the entire shape is. And there's a perpendicular line from the base to the opposite vertex. And this arrow here is telling me that this is 9.4 centimeters. So we have a decimal in this problem. All right, now I'm going to start solving. A equals 1/2 times 9.4 times 7. To multiply these decimals, I'm going to multiply every number in the bottom by every number in the top, just like normal multiplication. 7 times 4 is 28, so I'm going to carry my 2. 7 times 9 is 63, plus 2 is 65. Now what do I do with this decimal? Pause the video for a second to decide what happens with this decimal. If we were adding or subtracting, I would drop this decimal straight down. But because we're not adding or subtracting and we're multiplying, that's not what happens here, right? What I'm going to do is I'm going to take a pink marker and I'm going to circle every number that comes after a decimal point. This is purple. Every number that comes after a decimal point, I'm going to circle. However many circles I have, so however many purple circles I can make, which in this case is just 1, right? Only the 4 comes after a decimal point. That's how many times I'm going to move my decimal to the left. Just once for one circle, and my answer is 65.8. If you need more help with this, let me know, and you can do IXL on multiplying decimals. So come back over here. We're going to do 65.8 times 1/2. How do I multiply a fraction by a decimal? Same way you multiply a fraction times a whole number. You put the whole number over 1. We multiply across. 1 times 65.8 is 65.8. 2 times 1 is 2. And 65.8 divided by 2, right? Because fraction bar means division. So now I can take this and turn it into division. 65.8 divided by 2 is equal to 32.9 centimeters squared. See me for questions, take a quick pause break, and we're going to do number 8. Welcome back from your break. We have one more question to do. It says, Elena claims that the expression 1/2 4 times 4 times 5 represents the area of the triangle in square inches. Explain why Elena is not correct. Then explain how to correct her error and find the area of the triangle. All right, so there's a lot going on here, so let's break it down. It says Elena claims that the expression 1/2 times 4 times 5 represents the area of the triangle. So we know that this is pretty important. So I'm going to go ahead and circle that. I know I'm going to need this. I see I'm talking about area. I see I'm talking about triangles. All important information. So I'm going to take some notes. And we're talking about square inches. It wants me to explain why she's not correct and correct her error. So she says that the expression 1/2 times 4 times 5 is appropriate to find the area of this triangle. Let's remember our formula for the area of a triangle is 1/2 times the base times height. So let's double check her work. She has her 1/2, that's correct. You can get a different pen here. She has her 1/2, that part of her formula is correct. And then she finds her base. We said that the base could be any side of a triangle, and it looks like she used this one right here. I don't know for sure if that's correct yet, so I'm just going to highlight it so I know to look there, and then we're going to come back to this. I'm just going to move this over a little bit. There we go. All right, so then next, I know that here's my base. I'll make that green. I don't know yet if that's completely correct, but I just want to label it so I have something to look at. And the next thing we want to check on is her height. All right, let's look. Elena said that this is the height of the triangle. Take a couple seconds to look at this and decide, is she correct? Can that be the height of the triangle? Pause the video and think about it for a few seconds. Let's look. I know that to find the height of a triangle, I need a perpendicular line that makes a right angle that goes from the base to the opposite vertex. Remember, the vertex is a corner of a triangle or any shape. So I need a line that goes from the base to the opposite vertex. If this is her base, let's see. She has a line that goes from the base to the opposite vertex. But what is she missing? Is this a perpendicular line? Is that a right angle? No. Is this a right angle? Also not a right angle. So can this be the height if there's no perpendicular lines? No, right? 5 cannot be the height of this triangle. It's not perpendicular. So what is the height? Well, the base is still correct. We can still use this as the base. And what do we notice about this triangle? It's giving us a right angle from the base to the opposite vertex using this line right here that's labeled as 3 inches. Now I have my base, I have my height, which is a perpendicular line that starts at the base and ends at the vertex. And I see that this is 3 inches. So I'm going to correct her work by adding in a 3 here. And now I'm going to solve for the correct answer. So we decided that our base was correct. We decided that our height was incorrect, and that was what Elena did wrong. What she should have written was 1/2 times 4 times 3 to find the area of her triangle. Notice it did not ask you to solve. Yes, it does. It says and, so remember, read carefully. I'm not reading very carefully right now. It says I should have underlined this in the beginning. That's why it's so important to take notes so you don't forget anything. It says find the area of the triangle. So if you don't actually solve this, I can't give you full points. So let's solve. 1/2 times 4 times 3. We always start inside our parentheses because of PEMDAS. 4 times 3 is 12. How do I multiply a fraction by a whole number? I add a 1 underneath. I multiply across. 1 times 12 is 12. 2 times 1 is 2. 12 divided by 2 is 6. Your answer here would be 6 inches squared. Don't forget your units. Let me know if you have any questions on any of the problems that we just did. Here's another look at them. If you need, you can pause the video right here. If you need a better picture of this, let me know. If you have any questions, let me know. And don't forget to turn in your work.